Hello. Through a few examples we will get to know the application of series connection in various electronic circuits. The first example is standard. 2 resistors and power supply. It is necessary to calculate the total resistance Rx, current I, and voltages V1 and V2. We will first calculate the total resistance. This means that we will simply add the values of all the resistors, in our case, R1 and R2. Now we calculate the current. We simply divide the supply voltage by the total resistance. Next we calculate the voltages V1 and V2. The voltages on a single resistor are the product of the current and the ohmic value of the resistor. In the end we add the voltages V1 and V2, and if we get a voltage approximately equal to the supply voltage, it means that we calculated everything correctly. That's it. Let's go to another example that looks a little more complex, but isn't. We have a series circuit of 5 resistors, and we need to calculate the current and all voltages. We'll go a little faster. We calculate the total resistance again. Then the current through the circuit. Then the voltages. And finally we add them up for control. So, we did it. In the third example we have a classic exam task. They are known. Common voltage on resistors R2 and R3, and values of resistors, and it is necessary to calculate R2, 3, current, voltage V1, and supply voltage. We will first calculate the resistance R2, 3, because with Ohm's law below we can get the current I. If the value of the current I is known, then it is easy for us to calculate all the voltages. In this example, it is not necessary to calculate the voltages V2 and V3, but if you want to know how much they are, you can calculate them in the same way as V1. And that is it. The following 3 examples relate to the application in different electrical circuits. The next is a series circuit with a signal LED, in series with a resistor, which shows the status of a device, power on, or if it does not light, power off. It is a mandatory part of various chargers, laboratory power supplies, and so on. You can find out all the parameters of the diode from the manufacturer, and based on that, calculate the value of the required resistor for different supply voltages. The current through the diode is also the current through the entire circuit, including the resistor R. It means that we need to calculate the voltage VR. And then using Ohm's law to calculate the value of the resistor R. Although we got a value of 4.5 kilo ohms, we will choose the next standard resistor worth 4.7 kilo ohms. This will slightly reduce the current and brightness of the diode, but we get more stability. In the same way, we will calculate the resistor in the popular LED strip. The LED strip is composed of such blocks with 3 LED diodes and 1 resistor. By connecting these blocks in parallel, the desired length of the LED strip is obtained. You can also cut the LED strip to the desired length at the end of each block, so let's get started. We calculate the VR voltage by subtracting the diode voltages in series from the supply voltage. Then, using Ohm's law, we calculate the value of the resistance R. The last example seems naive, but you can easily make a mistake. So look to the end. We want to connect a 6 volts fan to a 12 volt supply voltage. That means, we have 6 volts more than we need. If we connect the fan directly, problems will occur quickly. Therefore, it is necessary to keep all the excess voltage on the resistor R. The fan current is also known, which also represents the current I. We calculate the resistor. Due to the total power of the fan, we cannot choose a standard quarter or half watt resistor, because too much load would quickly damage it. Therefore, the most optimal solution is to choose a 2 watts resistor. Then we are sure that everything will work properly. That's it. Thanks for watching.